Okay, this is the second review video, and I'm going to talk about solving trig equations, angular motion and unit conversion, and then arc length and sector area. So it'll be real quick. Okay, solving trig equations, right? We're going to use our unit circle to solve things like, let's see, root 3 times the tangent of x plus 1 equals 0. Okay, right? That is a trig equation that we have to solve for x. So we do the basic trig first, like we subtract 1, of course. Subtracting 1 is a pretty easy thing to do from both sides. And then we would divide both sides by root 3 because it's being multiplied, right? This is root 3 times the tangent of x. So I find that the tangent of x equals negative 1 over root 3, which we could simplify as negative root 3 over 3. So the last thing we do is we take the inverse tan, right? This is our math that we do in order to move the tangent from here to this side. We take its inverse. So x equals the inverse tan at root 3 over 3. So this means the angles, or angle, I guess there's two, angles where the tan value is negative root 3 over 3. Okay, so you go to your unit circle or your super chart if you have one, and you see where tan is negative root 3 over 3. And I see that happens at 5 pi over 6 and again at 11 pi over 6. So at these two angles on my unit circle, I know that the tangent has a value of negative root 3 over 3. Okay? Pretty simple stuff maybe. What about if I had sine squared of x minus 1 equals 0? Okay, so then I would add 1 to both sides. Sine squared x equals positive 1. And I would take the square root of both sides. Well, something we learned in algebra is that when you take the square root, you get positives and negatives. So our answers are everywhere the sign is either positive or negative 1. It's really important to remember when you square root things, you get positives and negatives. So sine is positive 1 at pi over 2 or 90 degrees, and sine is negative 1 at 3 pi over 2 or 270 degrees. So whenever we have a square in your trig problem and you solve it, you take the square root and you get positive and negative trig values. Okay, so don't forget about those two rules when it comes to solving trigs. Okay, linear speed and angular motion. So let me write a problem. Here we go. A wheel is turning at a speed of 400 RPMs, or revolutions per minute. What is the linear speed in miles per hour? Okay, so this is a conversion problem that we're going to start with simply by looking at the RPMs. So we're going to start with 400 RPMs. So that's 400 revolutions or rotations every minute. 400 revolutions every minute. So now I need to start my conversion. Let's first convert from minutes to hours. I know that there are 60 minutes in every 1 hour. Okay, so this is my true unit conversion. I have minutes on top and minutes on bottom, so they are able to cancel out. Okay. Oh, I guess I'm missing something here. How about we say it has a diameter, yes, I need a distance, diameter of 40 inches. Okay, I have a diameter of 40 inches. Sorry, that was some information I left out. 40 inches. Okay, so now we have our hours. Now we have to go from diameter. Diameter means it has a radius of 20, which is important to have a radius of 20. Okay. So revolutions, and we want to choose to, oh, we need to get rid of what's next. 20 inches per 1 revolution. Right? Nope, that's not right. 1 revolution is all the way around your circle, which is a circumference problem. So this has to be your 2 pi r. So radius of 20 times 2 times pi. Okay, so that is the complete one right there, the circumference. Circumference is 1 revolution. So 20 times 2 times pi divided by 1 revolution. That's how we get rid of revolutions. So now I need to go from inches, because this is in inches, to miles. Well, I can't do that directly. I have to go first. There are 12 inches in 1 foot. So then my inches can cancel out. And then I know that there are 1 mile has 5,280 feet. So there I cancel out my foot with my foot. So I have, let's see, on top, I have miles as my unit, and on bottom, I have hours. So now I just do all of my multiplication. I'm going to multiply 400 times 60 times 20 times 2 times pi. And then I'm going to divide that by 12 times 5,280. Let's see what I get. 43.18 miles per hour would be my final answer. Okay, so you do it unit by unit. That's how we start, right? With the given revolutions per minute, we convert from minutes to hours, and then we have to get rid of our revolutions. So we use the circumference of the circle, right? 2 pi r, or the diameter times pi. 2 pi r over 1 revolution, and that's how we get rid of that. And then inches, we convert inches into miles by going from inches to feet, and then from feet to miles. Okay, it's been a while since we did any of those ones, but that's how you do them. And then our last one, arc length and sector area. So if we have a circle, all circles have a radius. And then we're going to talk about the central angle. Okay, so what we can do is we can find the length of the arc, right? So the length of the arc in between our 2 radiuses. So this is going to be your arc length. Let's just call this arc length x. So here's your formula. X over 2 pi r. The arc length is a portion of the circumference, right? The whole entire distance around. The arc length is part of that. So if we compare the arc length to the circumference, well, that's the same as comparing the angle of the arc in degrees over 360, because the angle is part of 360 degrees. So this formula is only good if you have an angle in degrees. Okay, so if you have an angle in radian, then that's a different formula, but this is your degree formula. The arc length over 2 pi r equals degree over 360. And then if we wanted to find the area of this shaded region, it's basically the same proportion. So area we'll call capital A over the area formula, which is pi r squared, right? That's your area formula, is in the same proportion to the angle over 360. So if you're asked for an area, you better use an area formula. And if you're asked for an arc length, you use a circumference formula. Okay, so there's a little bit about solving trig equations, angular motion, right, and unit conversion, and then your 2 formulas for arc length and sector area.